Hello everyone, it's Mr. Spinelli, and today we're going to talk some more about factoring polynomials. But first, we're going to do a warm-up. And what I want you to notice about all of these multiplication problems is that they all involve 2x plus or minus 3 being multiplied by x plus or minus 2. So all of our coefficients are the same for these two binomials being multiplied together. Now what you'll notice is that in all of these, we're going to end up with a 2x squared for our leading term in standard form, because 2x times x gives me x squared. And then for our last term, all of these are going to have a 6, but it's either going to be a positive 6 or a negative 6. Now in the first one, we've got a positive 3 and a positive 2. Well, two positives multiply to make a positive. And in the one below that, two negatives also multiply to make a positive. So we'll have plus 6 for these first two on the left. Now for the other ones, we've got opposite signs on the 3 and the 2. So when we multiply a positive and a negative, we'll end up with a negative 6. So that's our constant term. Now let's see what happens with the middle term. So in the middle term, first I have to do the 2x times the 2, and then the 3 times the x. So 2x times 2 gives me 4x, and then I have to add to it 3x, because everything in this problem is positive. So I'll end up with plus 7x for my middle term. The one directly below it, I'm doing 2x times a negative 2, which gives me a negative 4x. And then I'm doing a negative 3 times an x, which gives me a negative 3x. If I add those two things together, I get negative 7x. So up here I had everything was positive. Now on these ones on the right, I've got a 2x and a negative 2, which gives me negative 4x, and a 3 times an x gives me a positive 3x. So negative 4x and positive 3x are being combined, which gives me a negative x. So notice that the 4 in this case is the bigger number, and since it's negative, that middle term is negative. That's going to be key as we start to factor. Now in the one below, now the 2x and the 2 give me a positive 4x, and the 3 and the x give me a negative 3x. So I end up with plus x. Okay? So in all four of these problems, my leading terms are the same because I multiplied 2x by x, and my constant terms at the end are all a 6, but it's just a matter of whether they're plus or minus, and that's indicated by whether we have the same sign. So in the first ones, we had plus plus and minus minus. So when you have an even number of negative signs, you end up with a positive result. So now let's dive into a basic problem to warm us up. So we want to factor this. So remember, our goal is to figure out what multiplies to make x squared. Well, the only thing that can multiply to make 1x squared is just an x and an x. So I know this is going to break into x and x. And that's the same for this problem over here. Now I have to think about what are the factors of 6. What two numbers multiply to make 6? Well, it could be 1 and 6 or 2 and 3. Now, the catch here is that I've got to multiply to make a negative 6 for both of these problems. So in order to make a negative 6, one of the two numbers from my factor pairs has to be negative, and the other one has to be positive. So I could have plus 1 minus 6, or I could have minus 1 plus 6, and then I could have plus 2 and a minus 3, or a negative 2 and a positive 3. Now, if this leading term hadn't been the 1 that we had, then we could have even more combinations. So now I have to figure out which one of these are going to multiply to make add to make this negative x term in the middle. Okay, my goal is to get my middle term to have a coefficient of negative 1. Well, the easiest way to do that is notice that I'm going to be multiplying x times all of these numbers, and then I'll be multiplying this x by all of these numbers. And my goal is to compare when they will add up to produce a negative x. Well, the thing is, the 1 and the 6 have a difference of 5, and since they're both being multiplied by a 1x, I know that neither of these two is going to work. Now, since I want my middle term to be negative x, I need to have the 3 be negative, the larger number of those two factor pairs. So this is going to end up being plus 2 and minus 3. Now, I have the same scenario of 4 options on the right-sided problem, but now I want to multiply to make a positive 1x. So when those two inner terms add together, I'm going to need to have a minus 2 and a plus 3. So let's take a look at some more examples and see what we can come up with. So in this first one, my a value, remember all of these are of the form ax squared plus or minus bx plus or minus c. So in this one, my leading coefficient is a 3. The only factor pair of 3 is 1 and 3. So I'm going to have a 3x and a 1x. I'm not going to write the 1 because I don't need to. And now I need to think of the factor pairs of 6. Well, we just did that, but they're 1 and 6 and 2 and 3. So now, the catch is I need to multiply to make a negative 6, which means that one of the factor pairs needs to be negative and the other one needs to be positive. So I could have a 1 and a 6, and these could be plus, minus, or minus and then plus. And then I could also flip it around to have the 6 first and then the 1. But if you remember from the other videos, I'm not going to put the 6 in the same set of parentheses as the 3 because that would have meant I had a GCF. And on this problem, my GCF is 1 because 3, 7, and 6, the only common factor they have is 1. So then I'm going to use 2 and 3. Well, I could have plus 2 or minus 2, and then minus 3 or plus 3. Again, I'm not going to use the 3 and then the 2 because I can't have a 3 with the 3x because that would have meant I had a GCF of 3 that I could have factored out at the beginning. So now, I need to consider what's going to happen when I multiply this 3x times all of these numbers, and then what happens when I add to it this x multiplied by all of these numbers. And the goal is to end up with a negative 7x. Okay, I know I'm going to satisfy the outside terms if I use any of these 4 pairs. So now if I do 3 times negative 6, that gives me negative 18, and then the 1 times 1 gives me 17. Sorry, it gives me positive 1, so negative 18 plus 1. This term would give me a negative 17x on the inside. That's not going to work. Now the next one, since all I do is swap which number is positive and which one's negative, I know the result's going to be a positive 17x, which also is not what I wanted. So I go to the next one. 3x times negative 3 gives me negative 9x, and then 2 times x gives me 2x. Well, negative 9x plus 2x gives me negative 7x. That is exactly the one I wanted. Now the last one would technically give me plus 7x. Which is not the one I want. So I know this is going to end up being plus 2 and minus 3. Now you always should do a quick check. So if I take this 3x plus 2 and multiply it by x minus 3, 3x times x gives me 3x squared. 3x times 3 gives me negative 9x. The 2 times the x gives me plus 2x. And the 2 times the negative 3 gives me negative 6. And these two terms combine to make negative 7x, which is exactly what I started with. So let's try another. And remember, I encourage you to pause the video, try it yourself, and then check your work with me. So on this one, I've got an a value of 4, a c value of 6, and those two do have a number in common. They have a factor of 2 in common, but the 5 in the middle does not have that factor. So the GCF here is 1, so my first step is done. Now 4x squared, that can be either 4x times x, or it can be 2x times 2x. Okay, remember I was thinking of the factor pairs of 4. They are 1 and 4 and 2 and 2. So that's why I have these two scenarios to consider. Now, 6 again, we've done this before, but our factor pairs are 1 and 6, and then 2 and 3. So now, because this 6 is negative, one of these has to be positive and the other has to be negative. So I could have plus 1 minus 6 minus 1 plus 6. And I should consider if I had 6 and 1 in the other direction, but I'm not going to put 6 with the 4 because they would have a common factor of 2. And I'm also not going to put the 2 with the 4 for that very same reason. So then I could have plus 3 minus 2 or minus 3 plus 2. Now, the bottom set to consider, the 2x and the 2x, I'm not even going to waste my time because 2x has a factor in common with the 6 and with this 2. So it can't possibly be this one because our GCF was 1. So now I've got to look at what happens when I multiply this 4x times all of these numbers, and then what happens when I add to it this x times these 4 numbers. So if I look at the first one, 4 times a negative 6 gives me negative 24x, and then x times the 1 gives me just 1x. That's going to give me a negative 23x. Not even close to the 5x that I want to get. The next one's going to give me a positive 23x because all that happens is the signs get swapped. So neither of those is right. The next one, 4 gets multiplied by negative 2, which gives me negative 8x. And then the 3 gets multiplied by the x, which gives me positive 3x, and my overall result is negative 5x. Well, that's not what I wanted. I wanted positive 5x, which is going to be the last one. So this is going to end up being minus 3 plus 2. And a quick check, all I got to do is check those inner terms, even though I just did that work. So the 4x times the 2 gives me 8x. Then the negative 3 times the x gives me negative 3x. This is a dot. Add those up, and you get the 5x, which was what our middle term was. Let's try some more. All right, this one's a nice one because our a value is 5, which is a prime number. And notice the other two numbers, coefficients, 17 and 12, have nothing in common with 5, so our GCF here is 1. But I know that this can only factor into 5x and x. So 5x times x will give me that 5x squared for that first term. And now I need to think of the factor pairs of 12. Well, 12's got quite a few. It's got 1 and 12, 2 and 6, and 3 and 4. Now this problem, I need to multiply to make a positive 12. And I need to add to make a negative 17x. Now the only way that I can multiply to make a positive and add to make a negative is if both of my factors are negative. So I'm automatically going to put minus signs in both sets of parentheses. Now I just need to consider all the different pairs. Well, I could have 1 and 12, 12 and 1, 2 and 6, or 6 and 2, 3 and 4, or 4 and 3. And now the goal is to get a negative 17 in the middle. Well, 5 times 12 is 60. Then if I add another 1, that one's going to give me negative 61x, which is way too small, or big in the negative sense. The next one's going to give me a negative 5x and a negative 12x, which together give me my goal of negative 17x. So I get my answer pretty quickly. So I've got 5x minus 12 and x minus 1. Okay, and again, a quick check. If I multiply those middle terms, I've got a negative 12x and a negative 5x, which together make negative 17x, which is what I was doing as I checked these numbers. So again, I wanted to multiply to make a positive and add to make a negative. So I knew that I could only have a minus sign and a minus sign. Let's try another. Oh, I notice right away that all these numbers are even, so I can factor out a GCF. And that GCF just happens to be 2. So if I factor out 2, I get 6x squared plus 7x minus 5. So now my real goal is to factor this guy right here. Now, the factor pairs of 6, there's 2 sets. We've seen them before. I could have 6x x and x, or I could have 3x and 2x. Now all I've got to do is consider my factor pairs of this 5. Notice the 5 is negative. So I need to have one of these numbers be positive and the other one be negative. So I could have +1 and -5, -1 and +5, or I can flip the order and have +5 -1, or -5 +1. And I can consider all of those same combinations down here. So I've got 8 different scenarios to consider. But what I notice is that when I do this 6x times these 5s, that's going to give me a 30, whether it's positive or negative, which when I have to multiply this x times the 1s, there's no way that 30 and the 1, that difference is 29. That's not going to give me the result I want. So these don't work. Those are too large. And then if I do the 6 times these, that's going to give me 6, and then the x times these is going to give me 5x. So these are going to be plus or minus x, which isn't anywhere near the 7x. So it's not even going to be any of these combinations. Again, that's my number sense. I've worked with these numbers. I notice what the product is going to be when I multiply them together. Now, when I look at the next one, I got a 3x times a -5. Remember, I'm multiplying this 3x times these numbers, and then I'm multiplying this 2x times the numbers in this column. So when I do that for the first one, I get -15x plus 2x, which is -13x, which means the one directly below it is going to be a positive 13x. Well, neither of those is the 7x that I'm trying to make for my middle term. So it's neither of those. So the next one, I know I want that middle term to be positive, so I'm going to need that 3 to be multiplied. Let's see. 3 times -1 gives me -3, and 5 times 2 gives me 10. I needed the 5 to be positive so that I get a bigger result. I need a positive result. So this right here is my winner. That's going to be plus 7x. The one below it would be negative 7x. So I need to do plus 5 minus 1. So when I ultimately factor it, I've got that 2 from my GCF. Then I've got 3x plus 5 and 2x minus 1. Of course, I could multiply all that out and double check my answer, but I'm fairly confident. All right, the next one. Now I notice that the x's are a bigger power, and again I have all even coefficients, so I've got to find that GCF. In this case, I want to look for the smallest exponent on x, which is this 2. So I'm going to factor out an x squared, and 2 is the largest coefficient I can pull out. So when I divide that first term by 2x squared, I'm just left with an x squared. When I divide the -4 by 2, I get a -2, and I still have one x left over. And the last term, I factored out all the x squareds, so it's just -16 divided by 2, which is -8. So now I've got to factor this term. Now when I look at this, I notice that the leading term is just a 1x squared. So that's going to factor into x and x, because x times x gives me x squared. So now I got to think of the factor pairs of my -8. Key is that it's negative, which means one of these numbers is going to have to be positive, the other one negative. And I want to add up those two middle terms to make a -2x. So I can have 1 and 8, and they can be positive or negative. And I could have a 2 and a 4, and they could be positive or negative. And I should probably write it upside down for the other side, since they have to be opposite. So the first one, since I notice I'm only multiplying x's, which means it's the same thing, I don't have to flip the order on this one and do 8 and 1 and 4 and 2. I notice that when I add up 8 and 1, when I find the difference between them, since one's going to be positive, the other one's going to be negative, I know that difference is 7. Well, the difference of 7 is not the 2 that I'm trying to make, so I know that neither of these is going to work. So now I know it's one of these. Well, which one is it? Since I want to get a -2x, I need to choose the bigger number to be negative. In this case, 4 is bigger than 2, so I'm going to do -4 and +2. And then a quick check. x times my negative 4 gives me negative 4x. 2 times the x gives me plus 2x. Negative 4x plus 2x gives me the desired negative 2x for my middle term. Let's try some more. All right, 4, 4, and 35 have no numbers in common, but I know that 4 has two sets of factor pairs, so it could either be 4 and 1 or 2 and 2. So this is either going to be 4x and x, or it's going to be 2x and 2x. Now I consider my factor pairs of the 35. Notice that it's negative. So because it's negative, one of them is going to have to be positive, the other one's going to have to be negative. So I've got 1 and 35, or I've got 5 and 7. So I can have plus or minus 1, minus or plus 35. Flip that, plus or minus 35, minus or plus 1. I'm not going to consider those because 4 times 35 is huge. And when I add or subtract the 1 from it, I'm going to get a number that's way bigger than the 4. Same goes the other way. So 35 times the 1x gives me 35x, which is just way too big. So those aren't going to work. 5 and 7 might be a little bit closer because they're pretty close to each other. So I've got plus or minus 5, minus or plus 7, plus or minus 7, minus or plus 5. But the thing I notice is that these two numbers, 5 and 7, have a difference of 2. But one of them's being multiplied by a 4x and the other one's being multiplied by an x. So that difference of 2 is going to be drastically modified and increased. But what I do notice, so I know that neither of these is going to work. You can check those for yourself. So I know that 5 and 7 are pretty interesting numbers. So I've got plus or minus 5 and minus or plus 7. And why do I look at this one? Because these have the same coefficient on my x term of 2 and 2. So if one of them gets multiplied by 7 and the other one gets multiplied by 5 of the opposite sign, they're going to have a difference of 2 multiplied by that number 2 to be a difference of 4, which is exactly what I'm looking for, a positive 4x, which means I need the bigger number, 7, to be positive and the other number to be negative. So if I do that, 2x times the 7 gives me positive 14, and then negative 5 times the 2x gives me a negative 10. 14 minus 10 gives me my 4 for that coefficient on the x term. So my factored form is ultimately this. So I'm just giving you my brief synopsis of how I see these numbers, and I want you to start thinking about them the same way. Oh, this one doesn't look like the others. Well, this is a binomial. So all I really need to look for is a GCF to start, as I always do. And the only thing they have in common is an x. So when I factor out an x, I get x plus 5, and that is my final answer. Distribute that x back in, and you get what you started with. There's nothing more I can pull out of x plus 5. So I'm done. Oh, another good one. My coefficient is just 1 on the x squared term, so I know that's just x and x. So this is one of the basic ones I want you to get really comfortable with. I like to throw some hard ones in too for you though. So this can be 1 and 18, 2 and 9, or 3 and 6. So whenever your coefficient on the x squared term is 1, you're in good business. Because all I need to look for is what the difference of these factors is. These have a difference of 17, these have a difference of 7, and these have a difference of 3. Ding, ding, ding. These have a difference of 3. I'm trying to make a positive 3, but I want to multiply to make a negative 18. So I know these have to be opposite signs. So I'm either going to have plus or minus 3 and minus or plus 6. Well, which one needs to be positive? Since I'm trying to make a positive 3x, I need the bigger number to be positive. So I'm going to add a 6 and I'm going to subtract a 3. Let's try another. Ooh, this one looks a little different too. I've got a negative in the very front. Whenever you have a negative, you should always, you don't have to, but I highly recommend you factor the negative out, which means I'm just going to change the sign of every single term, because that's what happens when I factor out a negative. Now I'm back to the normal business. I want to factor this term. So I've got to think of my factor pairs of 10. Well, they're 1 and 10 and 2 and 5. And the factor pairs of 6 we've become quite acquainted with are 1 and 6 and 2 and 3. So this is either going to be a 10x and an x, or it's going to be a 2x and a 5x. Now, this can be plus or minus 1, minus or plus 6, and I'm not going to put the 6 on the left side because 6 and 10 have a common factor of 2. They're both even. Same goes for the set of 2 and 3, so I'm just going to consider plus or minus 3 and minus or plus 2. And the same logic is going to apply at the bottom. I'm sure some of you were wondering why I didn't put the 5x first. Well, that's because the 2x is an even term, which means I can have the same setup on the bottom. So these are the 1, 2, 3, 4, 5, 6, 7, 8 different combinations I have to consider. That's a lot. Now remember, my goal is to add those two middle terms to make a positive 11x. Well, I know that 10 times 6 is 60. This one doesn't have a shot. Okay, but then 10 times 2 gives me 20, and 3 times the 1 gives me 30. So this is going to give me some combination. So 20 and 3 have a difference of 17. So this is going to be plus or minus 17x. Well, that's not going to cut it. And actually, I should probably write it correctly. It's actually going to be minus or plus if you consider the same order. So that's not going to make the 11x. So neither of these is going to work. And by the way, this top one would have been plus or minus 59x. Now the next one, 2 times the 6 is going to give me 12. And the difference of 12 and the 5 times the 1 gives me 7. So this one's going to give me plus or minus 7x, which is not 11x. So that one's not going to cut it. And the next one, 2 and 2 give me 4. 5 and 3 multiply to make 15. The difference of 15 and 4, because these are opposite signs, is 11. So this one is going to give me the desired plus or minus 11x. And I need the 5x to be multiplied by the positive 3 to give me a positive 15. And I need the 2x to be multiplied by a negative 2 to give me a negative 4x. So then 15x minus 4x gives me my desired 11x. And this would be my answer. Let's try another. And remember, as always, pause before I give it a go. Now this one looks really tricky, but it's not as bad as you think. So I've got an x and a y now in my problem. So it's the same concept. How can I multiply to make 4, that leading term? Well, it's either 4 and 1 or 2 and 2. And how do I multiply to make x squared? Well, x and x. Okay, well, we're used to this. This is nothing new. Okay. But now the question is, how on earth do I multiply to make 3y squared? Well, let's start with the negative 3. In order to make the negative 3, well, it's 1 and 3. That's my only options. And to make a negative 3, it needs to be plus or minus. So I need to do plus 1 minus 3, minus 3 plus 1, and I'll consider those same options down here. But now the question is, how on earth do I multiply to make a y squared? Well, I've got to have a y and a y in both spots. That's all that changes. So now, the first one, 4 times negative 3 gives me a negative 12, and then the other one gives me a 1. So I'm going to end up with a negative 12 plus a 1 gives me a negative 11, and then I'll end up with an xy. Well, that's not what I wanted. I actually wanted a positive 11xy, which is what this middle term is going to give me. So I'm going to end up with minus, where am I? Minus 3 and plus 1. So let's check this out. So 4x minus 3y times x plus y. Let's take a look at that. So 4x times the x gives me 4x squared. 4x times the y gives me plus 4xy. And then the negative 3y times the x, this is not the one. I'm going crazy. Did I add numbers wrong? Ah, Mr. Spinelli, what were you thinking? You wrote the wrong numbers next. You should have written -1 and +3, which would give us the positive 11xy. Okay, so we don't need to consider these terms because we found our answer right away. Let's fix that. Hopefully you caught that before I did. So this was +3 and -1. So I should have ended up with 4x minus y and x plus 3y. Thank you for your patience, and hopefully you caught that. Remember, I normally flip-flop who's positive and then who's negative before I switch the direction, because I would have then done next +3 and -1 and -3 and +1. And I would have considered all 4 of those options down here. But I didn't have to because I found my answer pretty quickly. So now, let's double check our answer, because Mr. Spinelli's going crazy. So 4x times x gives me 4x squared. 4x times 3y gives me plus 12x y. This middle term, negative y times x, gives me negative xy. Remember, x times y is the same as y times x. And then the last term, negative y times 3y, gives me the negative 3y squared. So I notice right away that I get my 4x squared and my negative 3y squared that I wanted to get. And then this middle term, these middle two terms, 12 and a -1, give me 11xy, which is exactly what I wanted. Let's try another, see if we can redeem ourselves. Very similar problem. So I've got a 6x squared, a negative 13xy, and a negative 5y squared. So with the 6, I know that that can either be 6x and x, or 3x and 2x. In order to multiply to make a negative 5y squared, I can have a positive 1 and a -5, a -1 and a +5, or flip the order, +5 -1, -1 -5, +1. And I'm going to have all of those options again down here. Now, in order to multiply to make the y squared, I've got to have a y on this last term for each of them. So now, I got to take a look and run through it. Well, the 6, remember, is being multiplied. The 6x is being multiplied by all of these numbers, and the x is being multiplied by all of these numbers. So that first one's going to give me a difference of 30 and 1, because 6 times 5 and 1 times 1, difference of 30 and 1 is 29. So it's going to give me a negative 29 xy and then a positive 29 xy. Well, that's not my desired negative 13 xy. So the first thing I notice is that these numbers are pretty disparingly far away. That's not going to give me that negative 13. The next one's going to give me a 6 and a 5 have a difference of 1. Well, the first one gives me negative xy. The next one's going to give me positive xy. There's not my answer either. So none of these work. Now the next one, 3x and 2x are very close to each other. So let's see what happens. When 3 gets multiplied by 5, I get 15. And when 2 is multiplied by 1, I get 2. The difference of 15 and 2 is 13. But I want a negative 13, so I need the negative number to be the bigger number. And since 5 is bigger than the 1, I know that it's going to be this combination right here. So I'm going to have plus 1y minus 5y. So ultimately I end up with 3x plus y and 2x minus 5y. And again, you can do a quick check. The 3x and the negative 5y give me negative 15xy. And then the y times the 2x gives me positive 2xy. Well, negative 15xy and positive 2xy give me that desired negative 13xy. Let's try another. All right, this one's got just a few more steps in it, because the first thing I notice is that there's a GCF other than 1. 12, 8, and 20 are all divisible by 4, and I notice that every single term has at least one x. In particular, it has at most one x. Sorry, at least one x. So now I divide through. 12 divided by the 4 gives me 3, and I still have 2 x's left. 8 divided by 4 gives me 2, and And I still have just one x left and that y. And then 20 divided by 4 with a negative gives me negative 5. All the x's are gone, so I just have y squared. And now this problem is very similar to the previous ones, except this one's even better because 3x squared, 3 is a prime number, so the only combination is 3x and x. And then again, to multiply to make that y squared, I know these terms are going to have a y. Now the only factors of that 5 are 1 and 5. And again, note that it's negative, and I'm trying to add to make a positive. So because it's negative, I know it can be plus 1 minus 5, minus 1 plus 5, or flip the order. Plus 5 minus 1, minus 5 plus 1. So when I do 3 times 5 and 1 times 1, I get a difference of 15 and 1 give me a difference of 14. So because these two have a difference of 14, those are not my winners. So I know that's going to be one of my last ones. And since I want to add to make a positive, I know that this 5 is going to have to be positive. Because 5 times the x gives me 5xy, and then the 3x times the negative 1y gives me negative 3. So 5 minus 3 gives me positive 2. So I'm going to have plus 5y minus y. So my end result is 4x times 3x plus 5y times x minus y. All right, let's see what we got next. Holy moly, Mr. Spinelli, what were you thinking when you made this one? 6, 25, and 25. No factors in common, so I've got GCF of 1 so far. That last term only has z's, and the other two terms have x's and y's. So there's no x's, y's, or z's I can factor out. So I've just got to start from the get-go. So how do I multiply to make 6? Well, we've seen this several times. It's 1 and 6 or 2 and 3. Now the question is, how do I multiply to make x squared y to the 4th? Well, to do that, I've got to have an x and a y squared, which means I can have xy squared with a 6 and a 1, or xy squared with a 3 and a 2. Now the question is, how do I multiply to make 25? Well, to multiply to make 25, it's 1 and 25, or 5 and 5. How do I multiply to make the z to the 6th? Well, I've got to have a z cubed. Okay, so now the combinations that I have to consider. Well, I need to multiply to make a positive 25 and add to make a positive. So I know that every single one of the combinations I should consider is positive. So I can have 1 and 25, 25 and 1, or 5 and 5. And I don't have to flip the 5 and the 5 because it's the same result either way. So these are the 6 combinations that I have to consider. 6 times 25, way too big. 6 times a 1 is 6, and 25 times a 1, well, that's not going to work because I need to add to make 25 xy squared. That's not going to work. So I'm probably going to be considering one of the ones where the inner terms are the same. 6 times 5 gives me 30, and 1 times 5 gives me 35. So this one won't work either. Now let's take a look at this last one. 25 is still going to be too big. So let's take a look at this guy. 3 times the 5 is going to give me 15. 2 times the 5 is going to give me 10. 10 and 15 add up to 25. So there's my answer. 3xy squared plus 5z cubed times 2xy squared plus 5z cubed. I'll let you check that answer. All right, now, these problems are really going to test your understanding of how to factor. So the goal here is to find all the values of k such that this polynomial will be factorable. So what I need to consider are, how can I multiply to make 4x squared? Well, we've seen this before. I've got 4x and x, or I've got 2x and 2x. Now, how do I multiply to make a positive 9? Well, the factor pairs of 9 are 1 and 9, or 3 and 3. Now the key is this is a positive 9, which means my factor pairs need to be the same sign. So I could have plus or minus 1 and plus or minus 9, or plus and minus 9 plus or minus 1, and then finally plus or minus 3 and plus or minus 3. Again, they need to be the same sign, so both positive or both negative. Now, I can have all those same combinations down below, but I only really have to worry about not flipping the 1 and the 9 because 2x and 2x are the same. So I've got these 6 on the top, 4 on the bottom, 10 total combinations, which means there should be probably 10 total combinations of k. Let's see what happens. Remember that I'm multiplying the 4x times all the numbers in this column. Same thing down here, the 2x times all the numbers in this column, which doesn't really matter the order. And then I'm multiplying the x times all of these numbers and the 2x times these numbers. So when I do 4 times 9, I get 36. And then 1 times the x gives me 37. Sorry, 36 plus 1 gives me 37. So this is going to give me plus or minus 37x in the middle, which means the k value would be plus or minus 37. So k can be positive or negative 37. Now with the next one, I've got 4 times the 1 gives me 4, and 9 times the 1 gives me 9. 4 and 9 add to make 13. So this term is going to give me plus or minus 13x, which means my k is plus or minus 13. Then for the last one, 4 and 3 multiply to make 12. 1 and 3 multiply to make 3. 12 plus 3 gives me 15. So this middle term will be plus or minus 15x. So now I've got plus or minus 15. And let's see what I get from the bottom. 2 and 1 multiply to make 2. 2 and 9 multiply to make 18. 18 and 2 add to make 20. So this term is going to give me a plus or minus 20x. So I've got plus or minus 20 to add to my list of possible k values. And then the last one, 2 and 3 multiply to make 6. And I have that twice, so 6 and 6 make 12. So I get plus or minus 12x. So these are all my possible values of k, such that this would be factorable. Now, some of you may say, well, do I have to include the negative ones because it was plus kx? Well, I said that any value of k. I should say any integer value of k. Integer means any whole number that is positive or negative. So any counting number, positive or negative. So there's 10 total values of k that would work such that this could factor. So if you want to have fun, write this problem 10 different times and factor it. But we've already done all the work. We know how it's going to factor. If it were positive 37x, it would be 4x plus 1 and x plus 9. All I'm doing is just reading across the top. Plus 1 plus 9 is going to give me a positive 37x. So I would know how to factor that. Same goes for the minus 1 minus 9 would give me a negative 37x in the middle. Okay, so now give this one a try. Same problem, but now the the 9 is negative. So I know I need to have opposite signs. So again, I know I'm going to have 4x and x, or 2x and 2x. Now in order to multiply to make 9, I know I've got 1 and 9, or 9 and 1, or 3 and 3, which I don't have to consider both orders. But notice now that I flipped this direction of the sign, it's plus and minus plus on the other side. And I would consider all of those down here, but I don't need to duplicate my work. I only have to do the 9 and 1 in one direction because it's the same the other way. So now 4 and 9 again give me 36, and 1 and x give me 1x. Now the difference between 36 and 1 is 35. So this is going to give me a minus or plus 35x. So now my k values, I've got plus or minus 35. The next one, 4 and 1 multiply to make 4, 9 and 1 multiply to make 9. The difference between 4 and 9 is going to be 5. So I'm going to get plus or minus 5x. So I got plus or minus 5 for my k values. And then with the 3 and the 3, 4 and 3 make 12, 1 and 3 make 3. The difference of 12 and 3 is 9. So I'm going to have minus or plus 9x, which means I can add plus or minus 9 to my k value list. Now down below, 2, all I really need to think about is what's the difference between 1 and 9? It's 8. And then 8 times 2 is 16. So this is going to give me plus or minus 16x. So I can add plus or minus 16 to my list. And then the last one's interesting. Because it's the same value, 2 times 3 and 2 times 3, but opposite signs, I'm going to get 0x. Okay? And I actually only am technically considering one of these options because both of them are the same. So I get 0x. So k could also be 0. So there's a total of 9 possible k values. Now what's interesting about the last one, when k is 0, 4x squared minus 9, this is known what's called difference of squares. If I take the square root of 4x squared, it's 2x. If I take the square root of 9, it's plus or minus 3. And because this is a difference of two things that can be squared, it factors as 2x plus 3 and 2x minus 3. The square root of each of those things, and then plus or minus. And we'll take a look at that later in a different video. Thank you very much for watching. Have a wonderful day.